Hello, my name is Hussein Yassine. I'm an associate professor of medicine and neurology at Keck School of Medicine of USC. I'm an endocrinologist by training, and my lab is focused on understanding brain lipids, specifically in Alzheimer's disease. We focus on ApoE4. ApoE4 is the strongest genetic risk factor of Alzheimer's disease. Up to 25% of the population carry one copy of the ApoE4 allele. And up to 50% of patients with Alzheimer's disease have ApoE4. As you probably know, we have no effective treatments that can modify or slow down the progression to Alzheimer's disease. We need a new understanding of the key elements that are driving pathology and key targets that could be investigated to stop this disease and its effect on our aging population. My lab has been fortunate to receive funding from the Alzheimer Association, from the Alzheimer Drug Discovery Foundation, from the National Institute on Aging, and from the Vranos Foundation. We have built an outstanding network of collaborators to identify key mechanisms of brain inflammation in the setting of ApoE4. Using an omics screen, we identified that arachidonic acid signaling is increased in dementia brains, particularly in those carrying the ApoE4. Using elegant molecular biology studies in ApoE4 targeted replacement mice, we've identified an enzyme known as calcium-dependent phospholipase A2, driving the increased arachidonic acid signaling. And importantly, we identified that inhibiting this enzyme ameliorates the pathology in these mouse models. Then we collaborated with Seva Catrich at Michelson's, screening 18 billion small molecules, and landed with 3 potential candidates that effectively can block CPLA2, verifying that information in vitro in the lab and using cell models. To be able to identify which patients might benefit from such an intervention, we developed an 18F arachidonic acid PET probe. As you can see in this figure, 18F arachidonic acid uptake in the brain is shown in red in ApoE4 targeted mice and correlates with brain inflammation. We believe this would be a useful companion to identify patients with brain inflammation that could benefit from CPLA2 inhibition. So what are the next steps? Well, we're seeking collaborations and funding to make a drug that can inhibit brain inflammation based on CPLA2 activation. We need to synthesize analogs that can cross into the brain effectively. We need to determine the PK/PD safety profile of these potential medications. And finally, we need to translate the 18F arachidonic acid PET signaling into the clinic. We are excited to share this progress, and you can email me at hyassine@usc.edu or visit our lab website, yassinelab.com. Thank you.